Hello and welcome to your geometry recorded session of the week. Welcome to December as well. Today is the 1st of December and we officially only have 3 more weeks left in this semester, so pretty exciting. I hope you guys all had a great Thanksgiving break and you're ready to finish the semester strong. Before we get started with the recording and what you're going to be learning this week, I did want to do a short warm-up as we always start with, and there's actually 3 questions this week. So please make sure you've got your math notebook out and you're ready to take good notes. And I'd like you to start with the warm-up problems in your notebook. So we're going to start with first reviewing what is a proportion. What is a proportion? And if you need to, you can always do a quick web search. You can Google it. To remind yourself what a proportion is. And then next, there are some proportions where you need to solve for x in the proportion. And we will be using this skill this week, and now is a great time to review what you learned last year in algebra and probably some prior years in math too about proportions. So go ahead and click pause now, and then when you're ready to check your work with mine, go ahead and click play. So what is a proportion? What is a proportion? So again, if you needed to do a quick web search, you are always welcome to do that. There's so much information for you guys available at your fingertips with the internet, so make sure that you use that to your advantage. If you ever have a term or something you don't know, you can always do a quick web search as well. So a proportion is when we have 2 ratios and state that they are equal. So for example, 1/2 equals 2/4. This is an example of a proportion because both those fractions are equal. 1/2 as a decimal is 0.5. 2/4 is also 0.5 as a fraction. So these 2 fractions or ratios are equal to one another. They're proportional. And remember, another way that we learn to tell if 2 fractions are in fact proportional is if we cross multiply. So if we take the numerator times the denominator of the other fraction, 2 times 2 is 4. And then if we do the same with the other denominator and numerator, 1 times 4 is also 4. So when you cross multiply, if you get the same product, that means that those 2 fractions are in fact a proportion. So 2 times 2 is 4. 4 times 1 is also 4, so that's another way. So if they are both the same fraction, when you divide them, or if you cross multiply them, you get the same product, you know that they're proportional. So let's look at the first question where we need to solve for x in a proportion. Well, I just said that the numerator and the denominator, if we multiply those together, they should be equal to the numerator and times the denominator of the other fraction. So we can use cross multiplication to help us solve when we have an unknown in a proportion. So I'm going to do the same thing here. I'm going to say 12 times x equals 3 times 20. This is just one way that we can solve for the unknown x in our denominator there. So 12x is going to equal 3 times 20 is 60. Oops, I forgot the x in there. And then to solve for x, we're just going to divide each side by 12. What is 60 divided by 12? If you said 5, you are correct. 60 divided by 12 is 5. So we know the unknown x variable is equal to 5. Another way you could look at it is look at 3. 3 times what will give us 4? Or 12 divided by what will give us 3? 12 divided by 4 would give us 3. Whatever we divided the numerators by, we have to do to the denominator. So 20 divided by 4 is also 5. So 2 different ways you can look at that. And then the second problem, we're going to do the same thing here. We're going to cross multiply to solve. So we're going to take 4 times 7. And we're going to set that equal to 6 times x plus 2. So 6 times x plus 2. So here we don't just have a single variable. We've got x plus 2 represents the unknown. So on the left side, we're going to take 4 times 27, which is 28. Remember, we've got 6 times all of x plus 2, so you have to put those parentheses in there so that you're sure that you are distributing, so you get the correct products there. So 6 times x is 6x, 6 times 2 is 12, so we're distributing. Then to solve, we're going to need to subtract 12 from both sides, and 28 minus 12 is 16. 16, we still have that 6x on that side. Is that right? Did I do everything there? 4 times that is 28. Okay. So now, subtracted 12 from both sides, and we get 16 equals 6x. I'm gonna continue over here because I'm running out of room. We need to divide each side by 6, and we're gonna get a decimal. We're gonna get a decimal. In this case, there was no whole number that when we multiplied times 4 times what gives us 6. So if we're focusing on the numerator, doing that other method that worked for the top, there is nothing times 4, no whole number times 4 would give us 6. So that's why, that's a clue here that we should be getting a fraction for our answer. 16 divided by 6, we are going to get a fraction, or we could just leave it as a fraction, so 16/6. And then we can divide out, and to reduce that fraction, we can simplify it. We can definitely divide each side, numerator and denominator by a 2 to help us reduce this to 8/3. 8/3, which is also about 2.6. But I'm going to leave it as a fraction because a fraction is the most exact answer. Instead of having a decimal where we have to round, the fraction is going to give us the most definite answer. Alrighty, so that's our review on proportions. You will be using proportions this week and the idea of proportions. You're going to see the idea of proportions when we learn about similarity this week. So I'm going to go to the next slide. If you need more time to take down the notes, go ahead and click pause. Otherwise, I'm going to go ahead to the next slide. Oops, I had a whole slide to do that on, and I did it. I squeezed it all in the first slide. Shucks. All right, reminders. Remember, you should be taking notes as you're watching this recording. Make sure you're checking your grades tab frequently, and not only are you looking to see just how you're doing overall, but you're actually clicking on the assignments to read my feedback in the individual assignments that will help you when you go to redo your low scoring assignments. Lots of work was submitted over break, so please be patient with grading. Remember, my first priority is to grade the current work, and then I go back and start redoing grading redos and missing work. So please be patient if you did some work over break. Alrighty, so today and the next 3 weeks, just a reminder that there is only 3 weeks left of the semester. The last day of the semester is December 18th. So just be sure that you, if you've got your goal grade of what you want, that you're working on getting there. You've got 3 weeks. So this week we're going to continue to explore Unit 4. We're going to be focusing on similar triangles and polygons. Similar triangles and polygons. So you're going to complete Unit 4, Session 2. You're going to do Unit 4, Session 3 this week. And then you're going to complete the Unit 4 quiz that's going to cover Sessions 1 through 3. And let's take a look at similar. I keep talking about similar. So what does similar mean? And I know you've studied this before in math, but let's do a quick review of the difference between what similar objects are and congruent, what those two words mean. So here's an example of two congruent shapes. We've got the same shape, they're both turtles, and they're both the same exact size. They can be oriented in different directions, but as long as they're the same shape and same size, then they're congruent. So when we've got congruent, you're going to have same shape and same size, which means that, I'm going to go continue over here, all the corresponding angles, so all corresponding all corresponding angles and sides are going to be congruent. When you've got congruent figures, same shape, same size, which means that all the congruent or all corresponding angles and corresponding sides are all going to be congruent. Now look at similar. We've got something different going on there. We can see for similar that we have the same shape. They're both turtles, but now we have different sizes. So we talked about all corresponding angles and sides being congruent with congruent shapes, where now we're going to learn something about the corresponding angles and sides of similar objects. So similar, what does it mean for any triangle, any polygon, any figure to be similar? So the corresponding angles of similar figures are always going to be congruent. So all the angles will always be congruent. They're going to have all corresponding angles will have the same exact measure. However, the corresponding sides are not, they don't need to be congruent. What they need to be is proportional. There's that word that we were talking about for our warm-up, and here we're seeing it. And make sure you're taking good notes right now. Make sure you're taking good notes, because you will see this week. So take time to write this down in your math notebook right now. And you're going to see a symbol a lot for similar. It's only part of our congruency symbol. So the symbol for similarity is just that little symbol. That's all. So congruent, remember, means same shape, same size. All corresponding angles will be congruent, and all corresponding sides will be congruent. And we just talked about that. We already took notes. And the symbol for congruent is going to have those two equal signs under the squiggly sign. So remember, all for congruent figures, all corresponding sides and all corresponding angles are congruent. Where for similar, only the corresponding angles are congruent, where the corresponding sides are going to be proportional. So we're going to put these ideas to use now, and we are going to spend some time this week proving that triangles are similar. So we're going to learn how we can prove triangles are similar. Remember back in Unit 2. It was Unit 2. In Unit 2, we learned, not Unit 3, it was Unit 2. We learned how to show that triangles are congruent. So remember, to show that triangles are congruent, we showed that all angles and all corresponding sides are congruent. Where now we're going to spend some time to learn how we can prove that triangles are similar. So let's do that right now. So here's an example of some similar figures. So how do we know that these figures are similar? How do we know that they're similar? So let's look. We learned that all corresponding angles must be congruent. So let's check that to make sure. So if these are oriented in the same direction, which is really nice. So we see that angle A and angle E are corresponding angles, and they have the same angle measurement. We see that angle F and angle B are corresponding. They have the same angle measurement. We see that angle H is corresponding to angle D. They have the same exact angle measurement. And last but not least, angle C and angle G are also same. They're congruent. So we see that all the corresponding angles are congruent. So that's one of the properties of similar polygons. We know that corresponding angles are congruent. We also learn that the corresponding sides need to be proportional. So let's look at the corresponding sides. So let's compare this side right here, I'm going to highlight in green, and this corresponding side here. So one side is 4 and the other length is 8 of the corresponding side. So the sides seem to be doubling. Well, let's see, and that would make them proportional. Let's see if all the corresponding sides double as we go from the smaller image to the larger image. So let's compare these two corresponding sides, side BC and side FG. We go from 4 to 8, those doubled. And you can keep seeing, if we look at this side, it's 3, this side is 6, so that doubled, and then 2.5 to 5, those doubled. So we can see that the corresponding sides are proportional. So that's how we are able to prove that those two figures are in fact similar. What is this scale? Well, it's twice as big, right? As we go from the smaller to the larger. Or we could, if we go from the larger to the smaller, we would say it's 1/2 the size. I'm going to go to the next slide now. So we're going to look at some postulates that look very familiar to us, but this time we're using them to prove similarity. So we've got 3 postulates that we're going to focus on this week. The first one is the angle-angle postulate. Remember, we actually couldn't use that in showing that 2 triangles are congruent, but we can use the angle-angle postulate to prove that 2 triangles are similar. So what that postulate says is that if 2 angles of one triangle are congruent to 2 angles of the other triangle, then the triangles are similar. So angle-angle is one of our postulates we can use to prove that triangles are similar. The next one is side-side-side. This is going to look familiar. If the measures of the corresponding sides of 2 angles are proportional, so here we've got a different word, proportional, where before to prove that 2 triangles are congruent, they had to be congruent. But now, because we're proving that they're similar, we just need to prove that the corresponding, all 3 sides are proportional. And then last but not least, we've got the side angle side for similarity. So if the measure of 2 sides are proportional to the 2 corresponding sides of another triangle and the included angles are congruent, then the triangles are similar. So here the big difference is that we're using proportional instead of congruent. So let's look and see which postulate proves that these 2 triangles are similar. So let's look at the corresponding sides. So this side here corresponds to this side. So how do we go from 5 to 15? What do we multiply times 5 to get to 15? 3. That would be our scale. And then is the same thing true when we look at our other corresponding sides? Do we multiply to go from 4 to 12? Do we multiply it by 3? We sure do. So we just to prove that 2 sides are proportional. And then we've got an included angle. Remember, included means it's sandwiched between the 2 sides. Remember, the angle has to be congruent. The included angle has to be congruent. In this case, it is. So we use the side angle side. Side angle side. And you'll get to practice doing that this week as well. Using these 3. You're only going to learn these 3 postulates. Angle, angle, side, 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 and side angle side. Alrighty, so let's now use what we know about triangles to help solve this. What do we need? So we've got some givens. We've got some given side lengths. And we need to find AE, so we need to find AE, which is this length here, and DE. We need to find both those legs. So remember, corresponding sides are going to be proportional. Corresponding sides are going to be proportional. So what is the equation that we would set up? Or proportion, I should say. I'm actually going to get rid of, let's do it this way. Let's look at our corresponding. So our corresponding sides are going to be, this leg here corresponds with this leg over here. So I'm going to write a proportion. And when you write your proportion, you've got to make sure that you're doing it in the same order. So here I'm doing 4/8. So I'm comparing, I can call this triangle 1. And I can call this triangle 2. So I'm comparing on the top, my numerator, I'm comparing triangle 1, and then I'm comparing it with triangle 2 on the bottom. Just so that when we go now to do the other set of corresponding legs, that we're doing it in the same order. So I want to make sure that 3x plus 4 goes on my numerator instead of my denominator, because we are comparing triangle 1 with triangle 2. And now we can go, we've got a proportion set up where we can solve for x. So we're going to need to do some cross multiplication. So let's go ahead and do that. I'm going to highlight in yellow here. So we're going to multiply these two. We'll do that first. 8 times 3x plus 4 equals, and then we're going to do the other 4 times x plus 12. 4 times x plus 12. And let's go ahead and distribute. So 3x times 8 is 24x. 8 times 4 is 32. 4 times x, we've got to distribute 4x. 4 times 12 is 48. Now we got to solve for x's. So I'm going to work on getting all my x's on the left side. I'm going to subtract 4x from both sides. And 24x minus 4x is 20x. I've still got that 32 hanging out. And I've got that 48 on the right side. Now to get, I need to subtract 32 from both sides. I'm trying to squeeze this all in here. I'm running out of room. 20x equals 48 minus 32. Gives me 16. And last but not least, I'm going to continue up over here. I'm going to rewrite the equation. Divide each side by 20. We do get a fraction, and that is okay. It's always better to leave your answer as a fraction instead of a decimal. It's going to be your more exact answer. So we can divide out, let's see, a 4 from our numerator and our denominator. Can we go any higher? 16 divided by 4 is 4. 20 divided by 4 is 5. Yikes, I started to write a different number there. It's going to be 5. So our answer will be 4/5. X equals 4/5. And you will get practice with doing the same thing this week. I'm going to go to the next slide. We're about done here. That is it. So that is our recorded session for the week. You guys, I'm sure, are ready for your key phrase. Remember, make sure you're doing the key phrase for the week of December 1st. And let's see here. Okay. So what does that say? It says, how is the side postulate different when using it to show polygons are similar versus congruent? So I showed you this week that we're going to use the side postulate and how we can use it to show that polygons are similar. So how is it different when we use it to show polygons are similar than when we used it back in Unit 2 to show that polygons were congruent? So tell me how it's used differently now. And that's it. So have a great week, and let me know if you need any help as you're working on any of the assignments this week.